Have you ever wondered which planet is the smallest in our solar system, and yet holds so many mysteries? Today we unravel the enigma that is Mercury, the innermost planet of our solar system. Named after the Roman deity, Mercury, the swift-footed messenger of the gods, this planet has a swift orbit of its own, circling the Sun at an average distance of about 58 million kilometers. That's a mere 0.39 astronomical units. Mercury's proximity to the Sun and its physical makeup make it an intriguing subject in the realm of planetary science. With its highly elliptical orbit, slow rotation, and unique day-night cycles, Mercury stands out from its planetary peers. Its dense metallic core, silicate mantle and crust, and significant gravitational pull despite its small size add to its fascination. Mercury, the smallest planet, continues to captivate scientists with its peculiarities. Mercury performs quite a dance around the Sun with its unique orbital and rotational characteristics. Mercury's path around the Sun is not a perfect circle, but rather an elongated ellipse, taking it on a speedy journey of 88 Earth days to complete one orbit. But here's the twist. Mercury spins on its axis at a snail's pace, taking about 59 Earth days to complete a full rotation. This slow pirouette, combined with its rapid orbit, creates an intriguing day-night cycle on the planet. A day on Mercury, from sunrise to sunrise, lasts a whopping 176 Earth days. That's right, a Mercurian day is twice as long as its year. Now that's a long day at the office. So if you've ever wished for more hours in your day, Mercury might just be your perfect vacation spot. Imagine a place where a day lasts twice as long as a year. Despite being the smallest planet, Mercury's dense composition gives it a significant gravitational pull. This celestial body is a terrestrial planet, characterized by a dense metallic core which accounts for a large portion of its mass. This core is enveloped by a silicate mantle and crust, akin to the Earth's own geological structure, albeit on a much smaller scale. Mercury's diameter stretches to approximately 4,880 kilometers, or in miles, a little over 3,000. This makes it the smallest planet in our solar system, yet its small stature shouldn't be mistaken for insignificance. The planet's dense composition, owing to its metallic core, lends it a significant gravitational pull. Despite its size, Mercury's gravitational influence rivals that of larger planets. This is a testament to the fact that size doesn't always equate to strength or influence. Small but mighty, that's Mercury for you. Mercury's surface tells tales of ancient volcanic activity and meteorite impacts. Its exterior is a battlefield of craters, similar to our very own Moon. Yet the scars that mark its face are not just remnants of celestial bombardment. The surface of Mercury is a kaleidoscope of geological features. It presents a dramatic contrast of landscapes, with regions of smooth plains punctuated by steep cliffs and craters. These craters are not mere dents on the surface, they are time capsules preserving the history of Mercury's tumultuous past. One of the most awe-inspiring features on Mercury is the Caloris Basin. This colossal impact crater stretches across an astonishing 1,550 kilometers in diameter. To put that into perspective, it's as if you took the distance from New York to Dallas and circled it into a crater. This basin is a silent testament to the violent collisions that have shaped the planet's history. But Mercury's geological story isn't just about impacts, it's also about the planet's internal workings. As Mercury's interior cooled over billions of years, the planet contracted. This contraction resulted in the formation of long, steep cliffs known as lobate scarps. These scarps, some towering over a mile high, crisscross the planet's surface, painting a picture of a world that's shrunk over time. Mercury's surface is also dotted with areas of smooth plains. These plains are believed to have been formed by ancient volcanic activity. Imagine rivers of molten rock pouring out onto the surface, spreading out and then solidifying, leaving behind a smooth, flat landscape. This volcanic past adds another layer of complexity to Mercury's geological tapestry. The surface of Mercury isn't just a static snapshot of the past. It's a dynamic, ever-changing landscape. It's continuously being reshaped by both external impacts and internal processes. And each new crater, each new scar adds another chapter to the planet's fascinating geological history. A surface that resembles our Moon, Mercury's geology is a testament to the planet's dynamic past. Mercury's atmosphere, or rather exosphere, is as thin as it gets. But that's not all that's interesting about it. This wafer-thin exosphere is made up of atoms that have been blasted off Mercury's surface by solar winds. Imagine an atmosphere so thin that its main components, oxygen, sodium, hydrogen, helium, and potassium, are all borrowed from the planet's surface by the sun's powerful gusts. This exosphere, however, isn't your typical protective blanket. It's too thin to shield Mercury from solar radiation or to retain any substantial heat. As a result, Mercury experiences some of the most extreme temperature swings in the solar system. When the sun is shining, temperatures on Mercury's surface can soar to a scorching 430 degrees Celsius. But when night falls, the lack of an insulating atmosphere allows temperatures to plummet to a bone-chilling negative 180 degrees Celsius. Now let's switch gears a bit and talk about Mercury's magnetic field. Yes, you heard that right. Mercury, despite being the smallest planet in our solar system, has a global magnetic field. It's about 1% the strength of Earth's magnetic field, but it's there nonetheless. This magnetic field is believed to be generated by a dynamo effect in Mercury's liquid outer core, much like Earth's. The discovery of this magnetic field was quite a surprise. It was first detected by the Mariner 10 spacecraft in the 1970s. At the time, scientists didn't expect a planet as small as Mercury to have a molten core, let alone a magnetic field. This discovery has since opened up new avenues of research into the planetary sciences, offering us a chance to better understand the magnetic fields of other planets. In the face of extreme conditions, Mercury still manages to hold a magnetic field, surprising us all. Mercury, our neighbor, has been visited by several space missions. The first of these was NASA's Mariner 10, which swung by the elusive planet not once but thrice in the mid-70s. This was a pioneering mission, providing humanity's first close-up images of Mercury. Among its numerous discoveries, Mariner 10 revealed that Mercury had a magnetic field, an unexpected find for such a small planet. Fast forward to the 21st century, and we see NASA returning to Mercury with the MESSENGER spacecraft, an acronym for Mercury Surface, Space Environment, Geochemistry, and Ranging. Launched in 2004, it took 7 years for MESSENGER to reach Mercury, becoming the first spacecraft to orbit the planet in 2011. MESSENGER's mission lasted 4 years, during which it extensively mapped Mercury's surface, analyzed its exosphere, and further studied its magnetic field. It also found water ice in permanently shadowed craters near Mercury's poles, a surprising discovery on a planet so close to the Sun. Today, exploration of Mercury continues with Bepi Colombo, a joint mission of the European Space Agency and the Japan Aerospace Exploration Agency. This ambitious mission, named after the Italian mathematician and engineer Giuseppe Bepi Colombo, launched in October 2018. Bepi Colombo will conduct a comprehensive study of Mercury, from its structure and geology to its magnetic field and interior. It is expected to reach Mercury's orbit in 2025. These missions have not only expanded our knowledge of Mercury, but also provided valuable insights into the formation and evolution of our solar system. Each new discovery opens up fresh questions, driving our curiosity and thirst for exploration. As we continue to explore Mercury, we can only expect to uncover more of its secrets. Mercury's unique conditions provide a unique laboratory for planetary science. Its close proximity to the Sun, combined with its extreme environmental conditions, opens up a wealth of opportunities for scientists to delve deeper into understanding planetary formation, the behavior of planetary magnetic fields, and the dynamics of exospheres. Studying Mercury doesn't just help us understand this tiny fiery world, but also gives us insights into the characteristics of other terrestrial planets, both in our solar system and in exoplanetary systems. Each discovery on Mercury paints a broader picture of the universe and our place within it, bringing us one step closer to unraveling the mysteries of space. In essence, Mercury is a world of extremes and contrasts. From its rapid orbit and slow rotation, to its scorching days and freezing nights, this smallest planet in our solar system is anything but insignificant. From its rapid orbit to its extreme temperatures, Mercury continues to intrigue and challenge our understanding of planets in our solar system.